Hello class, so we're going to be talking about triangle congruence. So this will be the second set of questions which we'll be working on. BF here is congruent to CF. And then EF, which is the shorter line segment, to FA. Now, then the first question which we have to ask ourselves is, wait a minute, given these two sets of congruent sides, which triangle do you think we can work with? In fact, if I were to highlight it, then it would have been something like this. A triangle that contains both sides, and then its counting point right up here. Now, then first, in order for us to prove that, then what we will be needing is the vertical angles. After proving those two triangles to be congruent, then what can we do? So when you look into our final conclusive statement has to be BC being congruent to BG. Which means this line segment has to be congruent to this line segment. Of course, we can try to do this one in one of the two ways. One way is proving these two small sets of triangles to be congruent, or the entire big triangle on top has to be congruent to big triangle on the bottom. Then, once we get that done, then we should be able to say by CP, CTC. So let us try to write this one up and then see what happens. This being the regions, and this being the statement. So first one, we're going to assume all of these things will be written right over here. And reasoning becomes given. Now, statement number 2. After saying that, we can say that these two angles must be congruent. Angle BFA and then angle CFE. Now, the reasoning will be vertical angles are congruent. All right, statement number 3. Therefore, we can say these two triangles that I highlighted with yellow and then its counting parts. Triangle ABF must be congruent to triangle ECF. Number 3, the reasoning here obviously becomes side angle side. Now, number 4. After proving that these two triangles are congruent, we want to try to go beyond that, which will be the outer triangle. This green triangle and its counting part. One thing that which we can do is we have one side that's already congruent. Now, second one could have been these two corresponding angles from the previous triangle. So we can say angle C must be congruent to angle B. Now the reasoning, yes, it becomes CP, CT. See, notice that this comes right after the congruent triangles. Now, statement number 5, then the next one would have been angle DFC, which is this vertical angle must be congruent to that vertical angle. Angle GFB. Now, number 5 will be the same as number 2. Vertical angles are congruent. Now, then we have all the necessary stuff for us to prove that the big green triangle on top must be congruent to the triangle on the bottom. DCF must be congruent to triangle BGF. Now number 6 becomes, yes, angle side angle. number 7. Then we can say the line segment DC must be congruent to line segment BG. Of course, the reasoning will be CP, CTC. All right, let us move on to the next question. Number 7. Here we have WT is congruent to TQ, and WX is also congruent to XQ. Then soon you should be able to realize that these two triangles must be congruent. The yellow highlighted triangle and to its counterpart. Now, when you look into this one, you will realize that two conditions are already met. The third one that's missing is the reflexive property of the line segment TX. Now, given that we can prove these two triangles to be congruent, next thing which we can do would have been what are they looking for? AX bisects the angle WAQ. That means ultimately what we need to prove is this angle must be congruent to that angle. This calls for either we are looking for the big triangle, which we could, or a small triangle on top. Since we have one condition, and then second condition here on the bottom by the corresponding angles, why don't we try to go for big triangles? In other words, I'm ultimately looking for proving triangle AXW. That's what I'm looking for. All right, let us get going. So here will be the reasoning, and then this will be the statement. First statement, like usual, we're going to try to assume that this has been written right over here. And then the reasoning will be the given. Statement number 2. Then we can say TX, line segment TX must be congruent to TX. Yes, the reasoning will be reflexive property. Now, number 3. Therefore, we can say triangle WTX must be congruent to triangle QTX. And statement number 3, the reasoning will be yes, SS. Number 4. After saying that what we could have done was we can say this angle must be congruent to that angle by CP, CTC. So we are looking at angle WXT must be congruent to angle QXT. Because the famous CP, CT, the corresponding parts, incongruent triangles are congruent. All right, number 5. Then not only TX is congruent to itself, but now this time we are looking for AX be congruent to AX. Of course, the reasoning would be the reflexive. Once we have that done, then what we can say is number 6, triangle WAX must be congruent to QA, the triangle QAX by side angle side. Now, statement number 7, then we could say the angle WAX must be congruent to angle QAX. Now, that reasoning must be, once again, CP, CTC. Now, then if you have to go further, statement number 8 can be written as an AX bisect angle WAQ. Now the reasoning is that a bisector divides an angle into two congruent parts. All right, so there it goes. Number 7 is done. Let us move on to number 8 now. So here we have side AB, and then it's congruent to BC. So we realize that these two line segments are congruent, and angle 1 and angle 2 are also congruent. Given that this is isosceles triangle, that makes the base angles to be congruent. But when you take away the smaller portions, such as angle 1 and 2, to be taken away, then the remaining angles must be also congruent to each other, which allows ultimately to say that triangle ADC is isosceles. All right, then let us write this one up together, statement and reasoning. First, we're going to assume everything is written on the given has been repeated. Now, statement number 2. Then triangle ABC is isosceles. Number 2, that's because two line segments are congruent, which is the definition of an isosceles triangle. Now, number 3, that allows us to say angle B, BAC, and angle BCA are congruent. Why? Two base angles in an isosceles triangle are congruent. And because angle 1 and angle 2 are congruent to each other, by subtracting, we get to realize step number 4, where angle DAC and then angle DCA. And this one is done by subtraction postulate. Then we can say the triangle, the final statement, ADC is isosceles. Now number 5, in a triangle, when two angles are congruent, it is an isosceles triangle. All right, so we have finished this question also. All right, so let's get started for number 9. Here we have angle 3 and angle 4 congruent. And angle 5 and angle 6 are also congruent too. Ultimately, somehow we want to prove that angle 1 and angle 2 are also congruent as well. Now, then we, in this case, we are looking for a triangle that contains angle 3, 4, and or 5 and 6. Now, one thing that which we can realize is since the two angles are congruent, we get to realize that triangle Q PS, these two has to be, this one has to be an isosceles triangle by the common denominator, common base. And similarly, for the other side of the triangle, QRS, that's also an isosceles triangle, which allows us to say that this line segment must be equal to this line segment. And then, so as this line segment must be equal to this line segment. And after that, we can either go for the addition postulate of these two angles or the reflexive property of the bottom. Let us try to write this one up together. So here it goes. We have statement and reasoning. First, I'm going to assume that these are all written as given. Number 2. And we can say line segment PQ must be congruent to PS. And also line segment QR is also congruent to SR. In the region is in triangles, sides opposite to congruent angles are congruent. So almost basically have the idea of an isosceles triangle. Statement number 3. Now, then we already sure about those two things. You can even say the angle PQR must be congruent to angle PSR. The reasoning will be the addition postulate. Now, then we can say the triangle PQR must be congruent to triangle PSR. By side angle side. That makes number 5. Angle 1 must be congruent to angle 2. By, yes, CP, CTC. Alright, so we'll stop here for the part 2, and soon we're going to continue for part 3. Have a nice day. Bye-bye. Bye.